Hi, my name is Crumb, and this is episode 1 of WORSTLANG. This episode will focus on the syntax of Esperanto since we already covered phonology in the teaser, which you should most definitely watch if you haven't yet. Just for fair warning, this does get pretty technical from a pure linguistics background, so let me know in the comments if I can clarify anything better, and I'll push out an addendum video if I'm just that horrible at explaining. Part 1. Logic. Since IELs should be as naturalistic and approximate real human language as much as possible, this is a logical language, because math is the language of the universe. A proposition is a statement that can be the case at a given time and place, like, I love you, or the quick brown fox jumps over the lazy dog, or simply, you walk. Dog with brown fur is not a proposition, because it is the case that dog with brown fur isn't really a meaningful sentence. Entities are objects, like the bear, or Germany, or a wood house, or chair. They're people, places, or things that take up space and time in the universe. Let's call the type of propositions capital T and the type of entities capital E. Let's also write the type of functions from A to B as A arrow B. What is the type of to walk? That square is just a placeholder, by the way. If we give it the subject the woman, it becomes the woman walks. If we give it a worker, it becomes a worker walks. This is a function that takes entities like the woman or a worker and turns them into propositions, so we can assign it the type E arrow T. Red, laugh, and cube are all similarly of type E to T. What about something like the verb to eat? If we give it the entity the frog, then it becomes the frog eats blank. It's easy to show that this itself is of type E to T, so to eat is a function that takes E and returns E to T. Therefore, it has type E to E to T. Exercise! Find out what the type of the verb give is. Okay, it's E to E to E to T. I'm so proud of you. We say a predicate is any function that returns T eventually. So everything we just previously mentioned is a predicate. What about this thing? Blank is the case at location blank? We can't just give it an entity like shoes, because otherwise it would become shoes are the case at location blank. So you have to give it another proposition. Doing this with the woman walks from earlier, we get the woman walks at location blank. And this itself is clearly E to T. Can you guess what to write for the whole predicate if it takes a proposition as input? That's right, it's T to E to T. Now, this isn't just a weird logic lesson. I promise this has application to linguistics. It turns out that pretty much everything, like nouns, adjectives, verbs, adverbs, conjunctions, cases, tenses, even voices, can be represented as predicates. This unification of parts of speech is what makes the algorithm possible, which we'll discuss in the next part. In the sentence, I eat an apple, there are two entities here. Let's call them X and Y. One of them can be described by the predicate of being me, and one of them can be described by the predicate of applehood. They're both subject to the eating predicate, though. This is a completely unintuitive and almost robotic way of thinking about sentences, which is precisely why it's perfectly bad for an IL. Part 2. The algorithm. Suppose we're in kindergarten and I want to epically destroy you by expressing my extreme dislike for you while pointing out your less than stellar appearance and intelligence. I would use these words. Wa, na, odi, homa, baka. There are two entities in this sentence. One of them is me and the other is you. I hate you and you're also ugly and stupid. Let's sort the predicates by decreasing number of subjects and index the entities. We can now input this into the algorithm like so, and we get some data. I'll just let you take this in for a bit. This means that this is the 8th possible sentence you can make with these words. It also shows you the permutation to put the words in. Nahoma wa odi baka. You'll never be able to set foot in Mrs. Baker's class again after I unleash that one on you. You can find the source code for the algorithm in the description below, but you'll notice that any sentence with 8 or so words or more starts to take a really long time to find. Instead of optimizing my program like an absolute buffoon, we'll alleviate this in other ways in the next video, which is entirely dedicated to predicates and the fun tricks you can do with them. See ya!